In Lesson 13, on page 112, we are continuing to talk about percents. So in our question, we're now talking about percent of change, which is relating how much something changes compared to its original amount. Nassim scores 5 goals in his first soccer season and 8 goals in his second soccer season. What is the percent increase in the number of goals that he scores? So the picture, it just gives you a visual. We can say that his change is going to be less than 100%. But I personally think the proportion way is a lot easier. But no matter which way you use, you're going to want to write these 3 things down. So every time you have a percent of change question, so for every percent change or error, because sometimes they say percent of error, you need to write down the original. You need to write down the start. The new. So original, then the new number, and then how much it changes. Because in the percent proportion, notice that the amount of change is the top of your proportion. So your change is the top of the proportion. The original is the bottom of the proportion. Notice the new number doesn't go anywhere in the proportion, only the change. Then it's still percent over 100. So for this question, our original number was 5. Our new number was 8. So to find a change in anything, we will subtract 8 minus 5 to get 3. They showed 8 minus 5 right in their proportion, but I think doing it this way helps you to not make little mistakes. So the change was 3 goals. So when we're setting up our proportion, it will be 3 was the change over the original of 5. And then 100, and we are looking for the percent. So that's where our variable is going to go. And when we cross multiply, we will get 60, but this is an interesting case because we are looking for the percent. We haven't found a question where we're finding the percent yet. So the 60 is over 100, so 60%. And then I forgot increase. So he had a 60% increase in his goals. So that means that the change 3 is 60% of the original 5. Now we're going to skip questions 2 and question 3. And we're going to go to question 4. So question 4, remember the hint I told you that you want to write the original, new, and change. Now read question 4 on your own so that doesn't take part of our video time. Make the video shorter. So original is still 5 because it says they want to compare his 12 goals from the 5 of the first season. The new is 12 and then the change is 7. And then you're going to set up your percent proportion. So the 100 doesn't change. We're looking for the percent. The original number was 5 and the change was 7. So it'll be 7 over 5 equals x over 100, and then cross multiply that. And when you cross multiply, you will get 140, but it is a percent. So that was more than a 100% change because 7 is more than 5. So you can have a greater than 100% change if your change is bigger than the original number. So question 5 says, what does it mean to have a percent increase of more than 100? That was just what we just said, that it would more than double. So in this case, 10 would be doubled. So 12 was our new number, which was more than 10. Now question 6, why does it make sense for the original number to be the denominator when you write a proportion to find the percent of change? It's just what we have been working with this entire time, that the original always goes with the 100%. Or we should say the original is always the 100% every time. Now try questions 7 and 8. So you should have found your original as 48, your new as 18, and the change, I did not write the change down correctly. Okay, give me 1 minute to fix that. I wasn't paying attention and I only typed 8 in my calculator. So it would be 48 minus 18 to get a change of 30. So 30 was the change, 48 is the original, and then x over 100, then cross multiply 30 times 100 and divide by 48, and you will get 62.5% decrease, 62.5% decrease. So they ate 62.5% of her muffins. So our original is 5, the new is 22, the change is 17. So when I set up my proportion, 17 was the change, over 5 was the original, equals x over 100, and I cross multiply, and we will get 340% increase in his apps on his phone. Now on page 114, we're talking about a different type of question. We're going to be talking about equivalent measurements and changing between measurements like feet and inches or kilometers and miles. So this falls in with percent because we can still use a proportion to solve it. Our question says the length of a park trail is 6.9 kilometers. Leo hikes the entire trail. How far does he hike in miles? Then they tell us 1 kilometer is 0.62 miles. You can absolutely do a double number line if you want to, but I think the not percent proportion, a conversion proportion is going to be easier. So they said they knew that 1 mile is 0.62, and then 2 miles they did 0.62 times 2, and then times 3, and then so on. So you could estimate that it was 6.9 kilometers is approximately 4.3 miles. But if we use our proportion, it's a lot easier. So they told me 1 kilometer is 0.62 miles. So in the conversion proportion, there's no percent, so there's no 100. So it's called conversions because we're converting kilometers to miles or miles to kilometers. So we're going to use our conversion factor. They told us that 1 kilometer is 0.62 miles. It doesn't matter which one you put on the top, the kilometers or the miles, as long as you do both the same. If we look at the equation or the proportion they already set up, they did kilometers over miles because 0.62 was miles and I did that backwards. 0.62 is miles. That's what I get for trying to remember things. So the 0.62 is the miles, so they put miles on top and the kilometers on the bottom. So you're going to use in the first part, you're going to use whatever your conversion factor is. You can just call that the conversion fact if you want to. So whatever the conversion factor is, that's what they'll give you. How many of the one things equals the other one? Then you'll plug in whichever one that they don't have. So you will either be given the first number or the second number. Like in this one, you were either given miles or kilometers. You'll either be given feet or inches. So you'll match the one up and then you will put a variable in the last place. So what they did, I'm rewriting theirs. You don't have to rewrite theirs if you don't want to. They knew that miles over kilometers, it was 0.62 miles equals 1 kilometer. And then back in the question, they said he was 6.9 kilometers. So 6.9 is kilometers. So 6.9 is the denominator and then x. And then cross multiply. And when we cross multiply, we will get 4.278. And that would be miles. Now you can skip 9, 10, 11, and 12, and we're going to skip ahead just to the practices, number 13 and 14. So we're skipping this and going straight to number 13. Remember, you're going to use the 1 pound equals 16 ounces for your conversion. Emma donates 180 ounces of cat food to an animal shelter. How many pounds of cat food does she donate? So I know I'm comparing pounds and ounces. I went ahead and put pounds on the top because pounds came first in our conversion factor. And 1 pound is 16 ounces, which is what they told us. So Emma donated 180 ounces. So that would be here 180 and then X. If you know your do I multiply or do I divide way, you can absolutely use that instead of the proportion. But I, a lot of times, have a hard time remembering, do I multiply or do I divide? But when we cross multiply that, we will get 11.25, and it was pounds. And the last question, Christopher fills an aquarium with 4 gallons of water. How many liters of water does he use to fill the aquarium? This time we're talking about gallons and liters. They told me in the question 1 gallon is the same as 3.79 liters. And then the number that Christopher is using is 4 gallons, so gallons went on the top and the variable on the bottom. Then you're going to cross multiply 3.79 times 4 divided by 1, and we will get 15.6 liters. So 15.16 15.16 liters of water.